So next is design steps for dewatering system. So we studied, so what is dewatering, so different objectives of dewatering, then different methods of dewatering. Then we are going to study design steps for dewatering system. Okay. A complete dewatering system should be capable of lowering the groundwater table up to a required depth, should intercept seepage into the excavation, and at the same time should remove the surface water which would affect the operation of dewatering system or construction. Okay. So efficient dewatering system have to lower the water table up to a certain limit. Okay. Up to a desired limit. Thus, the selection of an appropriate dewatering system and its design depends upon the geological, soil, water table condition at the site, magnitude of excavation, surface water runoff, and construction requirements. So, we studied many dewatering techniques, right? Many dewatering methods like well point, deep well, electroosmosis, etc. Okay, so we studied different methods. So, which methods have to be adopted in a particular site depends upon these factors such as geological factors, soil and water table condition at the site, magnitude of excavation, surface water runoff, construction requirements, etc. Okay. The essential steps in designing a dewatering system are, so which are the essential steps for designing a dewatering system? So first of all, subsoil investigation. So we have to investigate a soil, that is subsoil. So then only we can choose which dewatering system is suitable for such type of soil. Okay. So in subsoil investigation, importance should be given to know the characteristics of soil adjacent and beneath an excavation. അതായത് നമ്മൾ ഏത് ഡീവാട്ടറിംഗ് സിസ്റ്റമാണ് അവിടെ അഡോപ്റ്റ് ചെയ്യേണ്ടത് എന്നറിയണം എന്നുണ്ടെങ്കിൽ ഫസ്റ്റ് ഓഫ് ഓൾ നമ്മൾ സബ്സോയിൽ ഇൻവെസ്റ്റിഗേഷൻ ചെയ്യണം. അപ്പോൾ ആ ഒരു സോയിലിൻ്റെ ക്യാരക്ടറിസ്റ്റിക്സ് ഏത് ടൈപ്പ് ഓഫ് സോയിലാണ് എന്നൊക്കെ നമുക്ക് മനസ്സിലാക്കുകയാണെങ്കിൽ നമുക്ക് ഏത് മെത്തേഡ്സ് നമുക്ക് ഈസി ആയിട്ട് നമുക്ക് സജസ്റ്റ് ചെയ്യാൻ പറ്റും. ഓക്കെ. So if it is by doing subsoil investigation, we can identify the type of soil and the method suitable there. Okay. So if it is coarse grained soil, then we can opt for open well, deep well, etc. So if it is a stratified soil, then we can opt for vacuum dewatering method. Okay. So if it is fine grained also, we can go for electroosmosis method. Okay. So likewise, if you know the type and characteristics of subsoil only, we can choose which method is suitable for that. Okay. So for that we need to conduct subsoil investigation. The depth and spacing. So for doing subsoil investigation, that is for doing subsoil investigation, we need to collect the soil samples, right? So for that we have to drill boreholes into it. Okay. And so we need to collect samples from the boreholes. The depth and spacing of the boreholes have to be planned, okay, according to the stratification of the soil. Okay, actually in the site there may not be fully to the entire depth, there may not be fully sand, clay, etc. So they may be available in a stratified manner, right? So we need to identify which type of soil is present in the subsoil. So for that we need to do subsoil investigation. For that we need to drill boreholes and we need to collect the soil samples. Okay. And the depth and spacing of the boreholes depends upon the type of the soil and the depth of the each strata in the subsoil. Okay. Samples should be taken at frequent intervals so as to identify each soil type, permeability characteristics of the soil and layers of the clay or any other impervious material. So these samples have to be collected at suitable intervals so that we can identify which type of soil is present there, its permeability characteristics, etc. The position of the water table and substratum pressure should be carefully. So it's a very important thing. We need to find out the position of the water table. Okay. Then grain size distribution and permeability are the two important factors to be determined. So first of all, in subsoil investigation, three important details details are obtained. First of all, the position of water table, then the pressure of water in the water table, then the grain size distribution of the soil in the field, etc. Okay. Then permeability, etc. The second design step is first of all subsoil investigation. Second is source and water table details. Very important. The source of seepage and knowledge of water table and any substratum pressure at a site are most important factors to be considered while designing a dewatering system. Okay, so while designing a dewatering system, first of all we need to understand the source of this water flowing through the soil, and all the knowledge about the water table, the pressure of water in the water table, the position of the water table, etc. Okay, these are the important factors we need to know while designing a dewatering system. So the source of seepage depends upon geological features of the area, nearby streams or other bodies of water, on a degree of pervasiveness of the stratum and amount of drawdown. അതായത് എന്താണ് ഇപ്പോൾ സീപ്പേജ് എന്ന് വെച്ചാൽ ചിലപ്പം ആ ഒരു വെള്ളത്തിൻ്റെ ഒരു ഒഴുക്ക് കാണും ഒരു അടിയിൽ കൂടി, ആ സോയിലിൻ്റെ അടിയിൽ കൂടി. അപ്പോൾ അതാണ് സീപ്പേജ് എന്ന് പറയുന്നത്. അപ്പോൾ ആ സീപ്പേജിനെ ആ ഫ്ലോയിനെ റീഡയറക്റ്റ് ചെയ്ത് വിട്ടാലും മതി നമുക്ക് ഡീവാട്ടറിങ് മെത്തേഡായി. അതും ഒരു ഡീവാട്ടറിങ് മെത്തേഡാണ്, ഞാൻ തുടക്കത്തിൽ പറഞ്ഞായിരുന്നു. അപ്പോൾ ഈ സീപ്പേജ് വരുന്നത് എവിടെ കൂടെയാണ്, അപ്പോൾ അഡ്ജസൻ്റ് ആയിട്ട് സ്ട്രീംസ് വല്ലതും പോകുന്നുണ്ടോ, അപ്പോൾ അതൊക്കെ ആ ഒരു നോളേജൊക്കെ നമുക്ക് വേണം. ഓക്കെ, the streams close to the wells may act as line source of seepage depending on the distance of the wells from the effective source of seepage. അതായത് ഇപ്പോൾ നമ്മുടെ ആ ഒരു സൈറ്റിൽ അവിടെ കൂടെ സീപ്പേജ് ഒരു വെള്ളം ഒഴുകുന്നുണ്ടെങ്കിൽ നമുക്ക് അടുത്ത് എവിടെയെങ്കിലും സ്ട്രീം ഉണ്ടോ എന്ന് നോക്കുക. അപ്പോൾ അതിൻ്റെ ഡീറ്റെയിൽസ് കളക്ട് ചെയ്യുക. ഓക്കെ, അത് ഇമ്പോർട്ടൻ്റ് ആണ്. The flow may be from an aquifer being drained, the distance to which it is commonly known as radius of influence. Sometimes the flow of water through the site may occur not only because of stream but also because of the presence of an aquifer. So what do you mean by aquifer? Aquifer is a permeable stratum which contains water and transmits water. Okay, so it may be due to the presence of an aquifer also. So we need to collect details of all these things for proper design of a dewatering system. Okay, so this is known as radius of influence, means the influence of the site with this aquifer. The radius of influence may be estimated from the drawdown curve established from a field pumping test. So we can done a pumping test in the field, that is we can pump the water. So we can install a small well, okay, small well, then we can pump the water from the soil so that we can observe the drawdown of that water table around that well. Okay, drawdown means the change in depth of the water table. Okay, so that we can identify the radius of influence in that area. Radius of influence means what? The distance between that well or stream or aquifer with the site. So that is known as radius of influence, and it can be determined with the help of a field pumping test. So in order to ensure dry working condition during construction, it is preferable in most soil to maintain a water table 1 to 2 meter below the bottom of excavation. So in order to carry out the construction in a dry excavation, it is necessary that in all the construction field, this water table have to be lowered at a depth of 1 to 2 meter from the bottom of the excavation. Okay. So due consideration should be shown on the chemical properties of groundwater in the design operation. So along with the details collected about the soil, subsoil, and about the position of the groundwater table, we need to collect the details about the chemical properties of the groundwater as well. Okay, so this is all about the second step, that is source and water table details. Next is the third step, design of well point or wells from the source of seepage. So based on the field condition, the value of radius of influence should be ascertained. In this regard, the following considerations should be taken care of. Radius of influence, that is, here the third step is distance of the well from the source of seepage. If the actual radius of influence is very large, that is, if the stream or well or an aquifer is present at a larger distance from the site, okay, compared with the radius of the well, only an approximate estimation of the radius may be sufficient, since the discharge is not much sensitive to the value of R. So if the radius of influence, that is the distance between that well or aquifer from the site, is very large, then we don't need to determine this radius of influence with great accuracy. Okay, Then an accurate estimate of distance should be made for a dewatering system since the discharge is inversely proportional to L. So if the uh, radius of influence is very small, then the discharge of water or the seepage of water will be very high towards the site. So we need to accurately find out this radius of influence. So it can be carried out by using field pumping out test. The fourth design step is effective well radius. The effective well radius, that is gamma W or RW, for a well point or well is decided based on the installation of well with or without filter. So we can to find out the radius of the well, effective radius of the well is very important. So if a well point or well is installed without a gravel or sand filter, the effective well radius can be taken as 1/2 of the outside diameter of the well screen. Okay, I hope you understand. So around this well point, I already told you that a screen of a graded material is placed so that the water can easily enter into this well point. Okay, so if a gravel or sand filter, that is this graded material, is not placed around this well point, then the effective radius of the well can be taken as half the outside diameter of this well screen. When the gravel or sand filter is used around the well screen, then the well radius is taken as 1/2 the outer diameter of the filter. So if a well screen is installed without a filler filter in the pervious stratum, but a natural filter formed around the screen due to surgery, the effective well radius will exceed 1/2 of the outside diameter of the well screen. അതായത് ഇപ്പോൾ നമ്മൾ വെൽ പോയിന്റ് ഒക്കെ ഇൻസേർട്ട് ചെയ്യുമ്പോൾ ഞാൻ ഓൾറെഡി പറഞ്ഞു, ആ വെൽ പോയിന്റിന് ചുറ്റും നമ്മളൊരു പെർവിയസ് സ്ട്രാറ്റം ഇടും. അതായത് വെള്ളത്തിന് പെട്ടെന്ന് തന്നെ നമ്മുടെ വെല്ലിൻ്റെ അകത്തോട്ട് എത്താൻ വേണ്ടിയിട്ടാണ് അല്ലേ. അപ്പോൾ അതിപ്പോൾ ഗ്രേവൽ ഇടാം, സാൻഡ് ഇടാം, എന്ത് വേണമെങ്കിലും ഇടാം. അപ്പോൾ ആ ഫിൽറ്റർ മെറ്റീരിയൽ ഇട്ടില്ല എന്നുണ്ടെങ്കിൽ നമ്മുടെ വെല്ലിൻ്റെ റേഡിയസ് എത്ര കൊടുക്കണം, ഇട്ടാൽ എത്ര കൊടുക്കണം എന്നുള്ളതാണ് ഇവിടെ പറഞ്ഞത്. ഓക്കെ, ഇപ്പോൾ ഇട്ടില്ല എന്നുണ്ടെങ്കിലും എന്താണ് ഞാൻ പറഞ്ഞു, നമ്മളിപ്പോൾ ആ വെല്ലിൻ്റെ അകത്ത് വെള്ളം വീഴുമ്പോൾ ജസ്റ്റ് നമ്മളൊന്ന് ആ ഒരു ബോറിംഗ് ടൂൾ യൂസ് ചെയ്ത് ഒന്ന് അഗിറ്റേറ്റ് ചെയ്ത് കൊടുക്കും. അപ്പോൾ അഗിറ്റേറ്റ് ചെയ്ത് കൊടുക്കുമ്പോഴത്തേക്കും എന്താണ് അഗിറ്റേഷൻ സംഭവിക്കുമ്പം ആ ഒരു വെല്ലിന് ചുറ്റും എന്താണ് ഒരു ഫിൽട്ടർ ലെയർ ഓട്ടോമാറ്റിക്കലി ഫോം ചെയ്യും എന്നാണ് പറയുന്നത്. ഓക്കെ, the fifth design step is discharge computation. Okay, so this we can discuss in the next video.